Hello to everybody. My name is Vicente Botet, Escrivá. I work for Alcatel-Lucent in Lannion in France, a little town. And everything I do for the Boost community, it is on my free time. In my work, I have other imperatives. I'm in Spanish, and my main interests are in software engineering, language design, concurrency, parallelism. I am a co-author, maintainer of 3 libraries on Boost, Boost Ratio, Chrono, and Thread, and some minor utilities on Boost Utility. And I have started a lot of things that I have never finished. Some words about Boost expected, and maybe one day we will have this library in Boost. I hope that most of you know the talk of Andrei Alexandrescu about systematic error handling, on which he exposed the expected class, a little but useful expected class. What we have done is adapt this class with the interface of Boost of the proposed standard class optional, and we have added some functions that make expected, we can see expected as a monad error. We are currently working on a proposal for the standard, and I see that the proposal should be sent on a week if we want to see this proposal to be analyzed next June in Raspberry Build. And once the interface will be more stable, the open points will be clarified. Our intention is to propose this library for Boost, and if we have enough energy to try to port this library to older compilers, C++, 1999. The project was born on 2013 as a proposal of a Google Server of Code project, and this project was not retained because the student, Pierre Talbot, that works currently with me, have chosen other projects, and the system that is used on Google Summer of Code give the other project. Anyway, Pierre Talbot started just after the summer to work on this library, and we have worked more since the talk has been was accepted. You could find the library as it is now on the GitHub repository, and the proposal as in this web page. So what is expected? What is expected of ET? What expected of ET is quite close to optional T, but we want, in addition, to have the reason why we don't have the value T. Then we can consider that expected ET is either a T or the error E. Then I guess that most of you have assisted to the talk of David, and we have here the A or B, but with a special meaning for the first argument. The first argument, E, is intended to cover, to have the error. It is, and the second argument is to have the value we expect. Yes, David?
What is an error?
Okay. An error is anything you want to consider as an error. An int, a string, an exception, and anything.
So if it can be anything, then what use is it to say that it's an error?
Sorry, could you repeat?
I'm saying if it could be anything, then what's the utility of saying it's an error?
Okay. The question was, what is an error? In the context of this class is anything we want to put in this first parameter. I don't know if this clarifies.
You might be able to reword it as, how's it different than variant?
Sorry?
How is this class different than variant?
Okay. Then we can see expected ET as a variant of unexpected. The question, the comment was how it is expected different from variant. Then the single thing that we could say, the main difference is that E, it is here considered as an error. And we will have a different behavior, specific functions that otherwise I don't see how to provide. Maybe we will continue and we will come back to this difference between variant and expected. Then we have the expected is T plus unexpected E, but T cannot be unexpected E. Okay? In variant, for example, you could not repeat the same type. You cannot, if I understood, I cannot have variant int. This is why I have added this unexpected type, in order to be able to have unexpected int as a value, but also int as an error. And we want that expected ET behave as much as possible as t. This is why the first parameter is, with variant we are not able to make this difference. This is one of the main goals, is that we want to be able to use expected ET where we use t. And what we have done also is to add this explicit error type. Alexandrescu proposed an expected class that has always an exception pointer as error. We have added this explicit parameter in order to be able to have any kind of errors and be able to use this class on contexts on which exceptions are not desirable. Well, how do we declare and instantiate an object of type expected? As we have used as much as possible the same design as the proposed the optional proposal, and we can create an expected just using the make expected factory function that will have as parameter an instance of the type T, or we can use a constructor. We can assign expected of the same type. The type T could be also move only, and we can use, as in optional, in place construction, so that we can make the construction as efficient as possible. I will come back to the construction using this expect tag. For those that are not, I think that everything is aware, here in place is just a tag that make it possible to overload the constructor. Then we have seen how to make an expected that has a value. Now how we make an expected that don't have a value but an error. Then we have the factory make unexpected that takes as parameter an error and will return an unexpected type. Okay? But here we have on the left an L value of type expected. And we want to be able to build any expected from an error without giving explicitly which is the type of the value. Then we have decided that unexpected type is convertible to unexpected E is convertible to expected ET. Now to do also in place constructor for errors, we have added an unexpect tag, and this is why we have considered if we need to have an expect tag that it is more coherent with unexpected. But in order to be more close to the optional proposal, I think that we need however use in place. Okay. We have now that we can declare unexpected that it is default constructed. And the question is what is the state of this default constructed expected? And also to follow the optional design, optional defaults to null opt. That is, it defaults to the non-value of the type. Then we have decided that with expected, we have the same. When we default unexpected, its value is the unexpected value. And of course, this could work only if the error type is default constructible. Okay? In the case of optional, null opt type, it is default constructible always. In this case, with this default constructible property depends on the error. We have also followed the optional design in order to be able to do a reset with this syntax. I don't know on the standard committee how and why this was really something good. We have just followed the same design. If someone in the room knows why this was a good design.
Okay. The last one, it's the original author of the proposal for optional really
Yes.
liked that style. He really wanted that.
Yes.
It means you actually lose out on converting constructors. Like it can't construct an optional long from an int or whatever. There's a few cases where I can't construct an optional string from a thing that converts to string, because you get cases where this becomes ambiguous, right? Did you run into that? Something
Yes,
like that?
yes. Mm.
And it somewhat bothers me.
The comment was that this allowing this is in order to avoid ambiguity when we want to build an optional int from a short.
Yeah,
That's it.
that doesn't work because we lost that to gain this.
Okay.
So this was a style decision by the proposal, and we said okay.
What is the type of empty curly brace when you have it on the right-hand side of the sign? Is that an initializer
I
list?
think so.
Yes.
One by itself?
Yeah. So you have to check at runtime that the initializer list is empty?
I actually am not sure that is an
How-
initial.
no, it can't
I
be.
think-
It's a default.
I think that's why
it's
it-
like return brace.
It's the
whatever.
constructor. It's like
Yeah,
it knows
The
that it
constructor.
must be that whatever type EI is.
That's weird.
that's,
And
yeah,
it's default
Yeah.
constructing an EI.
That's nice because you can write a zero function that you just use curly braces.
Okay, I am not a good. I don't know exactly all the specificities of this. I have just taken and I will need to revise and understand better.
You know, it's not really something you need to think about for expected, but if we eventually have a variant, Variant, I assume, is gonna have an in-place constructor that in places, you know, I guess variant can have int twice, so you don't have the same problem. But I was wondering if we're gonna end up with in place 1, in place 2, in place 3, to know which one I'm in placing. Like, well, first we had in place, now we have expected and unexpected. In variant, are we gonna have 5 of them, or maybe it won't be a problem?
Okay. I propose to skip this point that I don't master very well. Well, on which context we want to use this class? Mainly, we want to use it when we return a value, but we want to also propagate an error. Then we will, most often, we will find that this class is the return type of a function. And we want to be able to check if when we call to a function that returns unexpected, want to check immediately if there is a value. Then we use the explicit bool conversion that will allow us to write things like that. We do assignment on the same time that we are testing, and if the read next char function returns unexpected that has a value, we process it, and we use the reference operator in order to get the value. This reference operator will not has a precondition that the expected has a value. Okay.
So if you have a function that returns an expected pointer, then you have to apply star twice?
No.
Did you reference the pointer?
When I reference the value.
But if the value is a pointer,
If the value here is a pointer,
if it's a char star,
oh, it's up to you to do what you want.
so yes, twice.
You could have an expected pointer and
Yes.
a cut pointer.
But
This is not fair.
you are telling me that here you need to use the reference twice?
If you want to dereference the pointer that's inside
But
the
yes, maybe I don't know if your functions expect a value and not a pointer. I don't know. Yes?
Do you overload the arrow operator?
Do you?
Just get, if it's a pointer, it just holds it.
Please repeat.
Oh, do you overload the arrow operator?
Arrow.
If it's a pointer
Yes.
that's held in it, then
Yes.
it just access it directly.
Yes. Do you overload the arrow operator, the indirection operator? Yes. We did. We have added it also not to be able to forward this indirection when we have a pointer like as value.
I'm not really comfortable with this use of star operators.
Okay.
If it's not a pointer, then why should I dereference?
I think that the idea is we have a class that wraps a value, but we are not sure that there is always a value, but it seems natural that we use the reference in order to get this possible value that is stored. It is not stored outside, it is stored on the same type, and this is in line with the design of optional. Then we have preferred to follow the same design in order that these types can be used.
Also optional also has.
Yes.
Overloaded. I see.
The next function is value. That has a white contrast. That means that when you use value and there is not a value stored or unexpected, we will throw the exception that it is stored in. Then
And it's not an exception.
When you invoke the star operator and there's no valid result in there, will you also throw an exception?
when we use, the question is, when we use the star, the reference operator on unexpected that has no value, that has an exception, do this the reference operator throw an exception? The answer is no. This is undefined behavior. This function has a precondition that the expected need to have a value. If you want to throw an exception, you will use the value function.
I just wanted to comment, that seems kind of unexpected to me.
It's like vector,
I kind of expect them to work the same for better or worse.
like vector at versus vector dereference, or vector square bracket.
Yes.
Yeah, I get that, and I'm not sure I'm happy with that either, but
Okay. The idea is, if we know that we have a value, we don't need to check again. If you don't want to care about if there is a value or not, just use value.
That too is like optional, is it not?
Exactly. The same thing. This is, if you want, this is the same as optional, but we have a little bit more.
in this questions that we're raising here, I presume they've already been discussed and raised in regard to optional, and they're kind of resolved. It's just, am I correct on that, or?
Half correct.
Huh?
They've been discussed, they're not resolved.
Oh,
That's why
okay.
optional is in a TS.
I see. So the same questions we would have about this, somebody has similar questions about optional,
Yeah.
and vice versa.
Yeah.
Okay.
The comment was, Robert, guess that all this discussion had already been
So I just want to say,
Done.
I think you're exactly right here, just to do whatever optional does, because then we
Yes.
just have kind of one thing
I will
almost, as opposed to
add,
two things
this
that
is
are somewhat different.
conformal to optional.
Okay.
Yes?
So one place where it seems like this class could diverge from optional is in storing the unexpected value in the bad access exception.
One way on which this class could differ from optional is how?
To store the value of the unexpected type that must be there in order to have thrown the exception. That's why we're throwing the exception, to store it in the exception and make it accessible.
Is the error
Yes.
exception.
Yes, and the difference is that the exception pool will have the error, and here, sorry, there is an error. We need to add bracket E bracket. Okay. Slide
Enter bracket error C.
E. Error C. Yes.
Has anybody considered the idea of just defining an expected object as a pair of an error object and an optional object, and then kind of just leveraging on whatever? In other words, making explicit the fact that we're copying or deriving from the, or maybe even just maybe even simpler, just inheriting from the optional, and having that extra error object, error object inside. Actually, now that I phrase it, I think it seems to me that it would be a candidate for defining in terms of one inheritance from the optional type, and then whatever they decide with the optional type, you
Okay.
got it.
The question was, have someone considered to define a class that has a pair of error and optional t in order to have this kind of behavior? Not that I am aware of, and I think that we need to encapsulate a little bit more. Pair is too general.
But what about deriving from optional?
Yeah,
You can't share storage.
Yeah.
yeah.
Well, no, I don't know about that, because, oh, I see, share storage between the error object and the other, because they're mutually exclusive, you're only gonna have one or the other. Yeah, okay, that's a certainly good argument.
I come back, you know,
I think that's a good answer.
the question, the comment of Eric was that here we are sharing the same space in order to store the error on the value. Okay.
So if this expected is actually contains an exception pointer, would
Yeah.
you throw the exception that's stored in the exception?
Okay, I have the example I have used. It is with an error that is not an exception pointer, and we need to wrap this error on an exception. And we have used the same design, optional use bad optional access. We have bad expected access. If the question was if the expected has an exception pointer, which exception will be thrown? Evidently, the exception that will be thrown is the exception that it is stored on the exception pointer. Okay. We could even throw error C.
You could.
We could. We can.
It would be simpler.
Maybe. What?
Good idea. That's
We can, because we can throw any type. Then,
I would vote for that.
if in order to be coherent, I will expect then that optional throw null opt.
But this is the case in which optional and expected could differ. Because optional has no default to
Yeah.
throw, right? Whereas
But
we
I
always
think
have
that
something to throw in expected. There's always
Throwing
something.
error C will be a valid, very valid option.
It's like a
Yes.
feature.
Yeah.
You see it?
It's like a feature, but synchronous. Yes.
I still think having something that's always derived from standard exception is a better idea. And even if this is just the base class and the value is contained in a derived class, but you have to parameterize your catch to get the derived, people can still catch on the base class.
Okay. The comment is that consider that it is a good idea to throw a specific class that could inherit of a base class that could be caught for any error. We could even think about on the mailing list from the standard proposal. There were some remarks about why I cannot state which is the exception that will be thrown. I think we can't do that Just we need to define a little bit more what is the interface of this error type. I have this on my to-do list. In the current implementation, we have the possibility of configuring which is the exception that can be thrown. And it consists in using expected with a type that wraps the error C type with the exception that we want to throw.
It's getting into this horse designed by a committee with humps.
The implementation that we have currently allows things like that. I have this on the proposal because it is more complex, but
in the code snippet above, you're checking to see that the result is true. And based on that, you proceed to use the value through the operator. What if it returns false? Can you then still get at the error?
what?
Instead of using try catch and the code above,
Yes, the answer is yes.
So there's a method get error.
The question is.
Here, yes, yes,
I
yes.
think the question was.
The question is,
what to put in error?
sorry,
The first.
the question is, could we recover the error?
No, in the first case.
No, in the first
How,
case.
how do we write the else case?
Yeah.
I want to say else, go look at
Yes,
the error.
there is a dot error method that has as precondition that we have an error stored.
Does it throw if there's no error?
And don't throws. No exception.
You can configure it.
And the question was, does this error function throws if there is an error? The answer is no. Yes?
So I've written some error classes before where if you tried to assign subsequently, like you were in a loop or a set of if statements, you tried to subsequently assign to a failed option that hadn't been checked for failure, that it would abort the
Okay.
process. Does this do that if you do serial assigns over the failure?
Okay. The comment is that there is some usage that we can store on this some kind of class that will be used to store an error. That if we try to reassign to already assigned error, some failure occurs. I have not considered this use case at all. Others have also requested, but what we want is that if there is an error, we need to have some way to handle the error. And if we have something that forces us to get this error, it is better. And someone has proposed that expected, if no one has observed the error on the destructor, it should call to terminate. But this is, you are talking about reassignment, and others have requested that we need to handle the error before the destructor.
In my team, people started checking errors after.
Again, by default, the class don't do that. we can configure using an error that does just this. If you define an error class that don't allow multiple assignments, you will have what you want. If you define an error class that call to terminate on the structure if the value has been not observed, then it's up to you to use the class. But as I said, this needs some kind of protocol between the expected class and the error class. Okay, this is globally we have see what expected provide in addition to optional. We'll see with more examples the monadic part using an example that has been used many times in order to explain how monads work. So I have no reference to all these. I have found a lot of tutorials that use these examples. Then, why don't use exceptions? Then we need to compare the code that we write when we use exceptions and the code that we write when we don't use exceptions and we use expect. Then we have this sample example of division that will check if the denominator is 0 and will throw a divide by 0 exception. This is code that is exception based. When we use the expected class from Alexander's Q, we will define this safe divide function like that. And instead of throwing an exception, we will build an expected int from the error divide by 0. And if there is no issue, we will return an expected int with the division that it is always possible to do in this case because G is not 0. And we found that we are repeating here expected int too much times. We found that here expected int is redundant. And this is why we define that the make unexpected is implicitly convertible to expected. And following the optional proposal, we have that T is also implicitly convertible to expected ET. Okay, then with this implicit conversion, we avoid to repeat the type that we want as result. We have that this doesn't change too much respect to the use of the way we are propagating errors when we use exception. Instead of throwing, we return make unexpected. Okay? The problem is that this function that with exceptions return an int, now it returns an exception and expect int. And it will be more complicated to compose these functions. Then I will skip this one because we have already see that value will throw an error. And even if we have already checked that we have an error, if we call to value, we rethrow the exception that was stored. Okay. Let me show you how we define a function that use the save divide function and calculate e plus g divided by k. Then we call to save divide. We check if q has a value. If it has a value, we do the e plus the contents of the division. Else, we propagate the error. Yes?
Why can't you just return Q?
Could you repeat?
Why cannot you just return Q?
In the second else case. Yeah, that's
Okay. In this case, we can. I have used explicitly make unexpected in order to state that we are propagating. In addition, take in account the case that the result was not int, but another type. Okay? Then it is clear not q. Okay? And the fact that we call to make unexpected will allow us to convert to any expected exception pointer, independently of the type of t. Sorry, the question was, could we return q directly? Yes?
So make unexpected in this case returns an unexpected with a expected exception pointer int inside.
No.
of it.
Make
So you
unexpected.
You crack that open.
Make unexpected will take the error that it is
Okay.
stored, it puts on an unexpected type, and this unexpected type is implicitly convertible to expected.
So it's overloaded for expected.
Yes.
So it's a moment.
So it's convertible to expected, yes. Yes.
So do you handle convertible types, for example, if Q was a unique pointer of a derived type and the return type was a unique pointer of a base type? Would that be a type error or would it allow the conversion?
If I had here a pointer to
If the if instead of int in the expected, if it was a unique pointer of a base and say divide or Q was unique pointer of a derived.
in this case, doesn't matter. The question is,
It's exactly that code. You tried to return.
does the library take in account if the parameter was an unipointer t
Convertible.
and the result of save divide was a unipointer u that are convertible, something like that. In this case, it is not important because we ignore completely the type. The type t is ignored.
But maybe go to the previous slide where you actually return and convert, right?
No, this one. No? More.
Where division is divided.
Here.
Yes.
Yeah.
Because you say return I divided by j.
Yes.
So if this were not integers,
Yes.
but you would have a unique pointer to derived class and the expected of unique pointer of base class.
Okay.
Would that do the conversion under
Yeah.
the
Okay.
expected?
Here we have a more adapted case to the question you have. The question is expected ET implicitly convertible from a type U that is convertible to T. I need to revise what I have done. I think yes. I think yes.
No.
No. No.
So if you go back to your
Why no?
if you go back to your slide where you do EI equals curly bracket,
This is the reason we cannot.
that only works because there's only one constructor.
Yeah.
So then you know what
Yeah.
the curly brackets mean.
This remember me something that there is an assignment with type U, but only if U is the same as T. Okay. I think that
It's an optional design question.
yes, it
You'll
is
do whatever
quite tricky as design. Okay. It is clear that this is not as clear as if the function throw an exception. We are checking. This is clearly not good code. It is clear. We know what they do, but it is not. Good code. Then we can use a function that will take care of this condition. Has expected a value or not, then call the function if expected has a value, return otherwise propagate the error. This is what fmap does. The name is the same as the Haskell fmap function. It is used when the parameter expected is seen as a functor in the sense of Haskell. Okay, a functor is just that, something that accepts this fmap function that allows to call the function only in a given context. David?
So a bit of history behind the reason why they call that fmap. They really wanted to call it map. And they called it fmap because map was used for lists. But since we're in the C++ context and we don't have another map which is competing with it, it might be...
We have
Map.
good map. We go.
But it's a member function, not a free function.
Okay. Then you are suggesting that instead of calling this function fmap in C++, we could call it just map. Okay. It seems that.
If you have proper scope.
Okay.
Transform.
The problem could be when the function it is not a member but I am of course, open all this backshading about the names, and the better the names are, the best.
And this could be implemented as a free function. As
Right, and then we could.
Yes,
roll
we
it.
will. We will. Then, of course, the function that we pass could be a lambda. We can use bind. We can use whatever we want as a function. Let me continue with now the function, instead of throwing only one exception, it would throw two possible exceptions, and we will define a function that will try to recover from one of the errors. Then this is the exception-based code. We define an exception if the values are not divisible. In this case, we will throw a specific exception. Okay? And now we have someone else needs to use these safe divide functions, but for him, even when the value are not divisible, they want to use integer division. Okay? Then this is the code on exception base, and this is the code using expected. Here I have used the same function proposed by Andrei Alexandrescu, has exception, and it works because we have access to E and G, because has exception, not divisible, don't allow you to have the data that it is stored on the exception. Okay, this works in this case. In order to be able to take the information that is stored on the exception, we could use this dot catch exception function that will request to have the exception we want to catch. I have used here O2 from C++ 14 in order to don't duplicate this information and just we access to the data provided by the exception. This function, as the previous one, has exception, catch exception. In my opinion, are expensive because we need to do a try-catch in order to do the pattern matching of the exception. I would like to have another way with exception pointer to be able to let me know if you have this exception, or give me this exception. I know that you have it, or as we could do with, for example, the class any. The class any is able to store a lot of things, and we are able to get with a dynamic cast, any cast, we are able to obtain the stored data. With exception pointer, we are not able. Okay. Okay, let me continue in order to see how this scale. We have two calls to safe divide. and we see that we are repeating the same kind of code, and this is ugly, but this is not less ugly. We need to embed the function calls with using fmap, and here we use also mbind. Mbind, that the single difference is that the function we pass is a function that returns unexpected already. Okay? Then this is the way we could work with this kind of mbind map functions, but it is quite good. It is maybe better than the previous one, because here we don't see the error propagation. Okay, but then in this case, in this particular case, we could call directly to the free function fmap that will call to the function if all the expected values contain a value. In this case, this will be a better design. And it would be great if we could have something, an expression that allow us to write the things in a more structured way, sequential way, as Haskell does, and it is also something similar to the await proposal, in the sense that we continue if there is not an error, and otherwise we propagate the error. It seems to me that this kind of code could be more easy to write, understand, but of course will need a change on the language that it is always difficult to justify. And the translation could be something like that. See that now I am using.
That would be sort of, I'm sorry, it was sort of instead of the resumable functions proposal, which is also a change to the language. This is much more general than resumable functions.
I have not worked on deep on this. I am not sure what are the problems. Then I don't want to but to say that this could be more general than the await proposal. What I say, it is more restrictive in the sense that we are using it only on one expression, not any way on a function. It is different. Anyway, this could be translated, transformed to this expression, and here I use mbind as a free function in order to be used by any type that define the overload for mbind. David, you raise it. Waiting for change on the language. Do macro. It works. It is a macro. This is the first macro that I wrote, to avoid. And here I use a microspec that just do this kind of if. The code that we have used, see the flat code. We don't use at all mbind. Okay? It's a possibility in some specific cases. For expected could work, not for any monad.
So is boost join like a monadic join?
No, it's preprocessor done.
This
Is that
is,
just like token combining?
sorry?
Is the boost join just like token combining, like the?
Yes. It's Bustion as the concatenation of the sample, yes. Okay, just an example that from the presentation of Alexandrescu, a little bit modified, a way to get an int, exception base, a function that matches string, and a way to get an int range with a syntax e.g. With exceptions, it is quite clear. This is a hypothetical input string range with 2 iterators. And with expected and the do notation, we have something that is quite close. Here, instead of doing assignment, we do this kind of assignment controlled by the result. Well, it seems that the time I will skip much more of this section on which I show how some of the something were implemented. It was just to, I think that the main point is that we define an expected type that it is implicitly convertible, but that the construction from an error is explicit. I think that it is something similar of what we could have if we define a complex class that is implicitly convertible for, an imaginary class, that it is explicitly convertible from an int, from a float. Okay? This is something similar. Here, it is the overload we were calling before for making expected. It is not really needed, but I think that is explicit. We propagate the error. Then we have decided that expected it is not convertible for E. It is for that we have created this unexpected type. And the opposite, it is not true. We cannot retrieve implicitly we have no conversion implicit towards the unexpected type. We use a specific get unexpected type or the make unexpected that we have overloaded. For the value is the same, implicit conversion, and sorry. Yes, this is a point specialization for exception pointer. Because we want to accept any exception when we build unexpected. Then we are not only convertible from unexpected type exception pointer, but any unexpected type. Yes?
So if the expected has a conversion from unexpected type, and it has a conversion from T, right? I can construct
Yes.
an expected from unexpected or a T. Then the E equals curly brackets probably doesn't work anymore.
Okay.
Maybe, yes?
I think it would.
I have tested. The question is that the comment is that if expected is convertible from T implicitly and unexpected E, the expression E equal mustache will not work. I don't know how you spell it. Will not work. I think that I have this in my test. Then we could check later. Okay. I have some doubts about the default constructor. When I have an exception pointer, when I have an exception pointer, the default constructor will construct an exception pointer that has no exception. But the expected has no value. Then when I try to get the value, I will not have an exception to throw. Then either, in this case, we have undefined behavior, either we throw a specific exception. The current implementation throws an explicit exception, because we consider that it is important that the expected is default constructible. But, yes?
So the default constructor puts it in an intermediate state where there's no exception and there's no value? Is that right?
Yes, it uses the default constructor of the error, and the default constructor of exception pointer is no exception, but an exception pointer with no exception.
Why
It is not.
construct an
The question-
exception pointer with the exception that you will throw if there is no exception pointer in it.
Yes, I can decide to default construct an exception pointer with an exception already. It's the same.
I'm just curious, do you know what happens if you, what is it, it's called
Rethrow.
rethrow exception? It's a function
Undefined behavior. Undefined behavior.
with a default constructed exception.
Yeah.
function? It's undefined behavior?
The question was, do you know what happens when you rethrow an exception pointer, a default constructor exception pointer? Undefined behavior. You need to know if there is something or not. Okay, with some mistakes here, but all the operators, pointer-like operators are there. Don't ask me, I will take too much time why we have three different overloads. And this is the imagine the M stands for monad or expected, or the future proposal has a then function that has a parameter that has a feature and returns a feature, and the function could return either a type or a feature. Then I have tried to I think that both in Haskell we have that fmap applied to a function from T to U, returns a monad by this one. If I have okay, the function returns already unexpected, we will wrap the expected twice. This is with the fmap function. With the mbind function, we don't wrap. We don't wrap it. Okay, this is the main difference. Okay, and the catch error or catch exception need to return the same type. We can recover, but we don't change the type. The definition of these functions are really simple and there are a lot of errors on the slides, and I will escape them. There are a lot of errors. Minor errors, but they are there. I will skip this one. Yes?
Have you considered making expected not be default constructible?
Yes. Have you considered to make expected not default constructible? I think that the best we can do is the single case we have, it is this exception pointer. If we agree that we could define an exception, that means we don't have it. It is like if you initialize your error as, I have an error, I don't know which error is. But by default, I have not a success. I need to add a value, to set a value in order to say the function has succeeded. I think it's preferable to have this default constructor, but yes.
So in Kestrel, you don't have the default constructor.
No.
So I'm wondering what's the use case here for the default constructor? There's some kind of container you want to store these in that requires it? Or?
Containers, of course. The question is, Haskell doesn't have default constructors. What is the use case for this default constructor? Just the idea is to be able to store them on a container, on an array if you want. You need you want to store them in array expected ET, and after that you can initialize and use them.
Yeah, once you have mutation and composability requires to have default constructors. So you want to have an object that contains the stuff and then you set it later. Like in Haskell you cannot set it later. Period.
Let me discuss about this point, because I am not. I have also some depth that I would like to share with you. How to expected are compared, and following optional, unexpected values are always less than expected one. But how unexpected compare between them? Exception pointer doesn't compare. Would we expect that expected exception pointer compare and compares as optional t? Does mean that all the exceptions compare equal? I don't know. From the this could be counterintuitive, because the type is observed differently, because we can have different exceptions. Then, for the time being, we have decided that expected exception pointer is not comparable. And expected is comparable if E and T are comparable. Here's the definition. There's nothing complex here. Here are the factors associated to the expected class, make expected without parameter, build a expected void. We have a specialization for void because even if there is no value, we can use expected in order to propagate the errors. Have a specific function in order to carry the current exception. No. Able to make an expected from an error. We have the implicit conversion, but sometimes we want to state that we want an expected value. Then this function could be used, make expected from exception or make expected from error in order to say the result is expected. And the previous one worked for exception pointer because we need to have an expected an error by default. But when we want to build an expected that it is not associated to an exception pointer, we would like to do something like that. Pass the error type as parameter. This I have not reached to do it. Or just use the default constructor and the int in this case is redundant. Or this is the trick that I have found is to consider that expected the error C is a type constructor for the expected ET. And what I have is that the class T is default with a holder, and we have a specialization. And with this holder, we are able to define this make function that with the template parameter T and the template parameter E is able to build an expected ET. Then this allows us to build to have a factory that not only is able to make expected with the default exception pointer, but also with a specific error. And I think that this function make, we could define a make functions, a non-member function make, that could take as parameter a type constructor that will be able to build anything. And we will be able to have make optional, make expected, make ready feature, all of them using the same interface. Make the type constructor. I have not too much time to we see that we have one class that have a specific case for the exception pointer that make it quite different from a class that use any error. And I am wondering if these two classes shouldn't have a different name, because they don't behave the same way. We don't have relation operators. The default constructor is not convenient. we could not hash, in this case neither. We could not have hash exception or catch exception in this case. I think that maybe we need two different names. Okay, I think that the time is, and I will skip some comparison I had with bus variant, bus optional, and feature. The idea is that all these types share a lot of things with the same semantics sometimes, and that it will be could be great that we could use these classes with the same interface. Then what is the common interface between these classes? Should we add things to optional, to feature, or maybe should we add functions as non-member functions that could work with any type? This is what I want to work on. I have started, but I have not found yet something that satisfies me completely. The we wanted that the expected ET behaves as a T. Then I'm not sure if the error must condition the quality of expected ET. Because it is accidental. It is not, we can consider that all errors collapse on the same thing.
Maybe it should behave similarly to not a number. Right? Not a number is an
Yes.
example of a double that has a
I don't know. This.
Not a number does not compare to any other number.
Yes.
Maybe a separate member function for comparing that obscures the unexpected value.
Maybe using a different function for comparing when we collapse could be a good idea. Yes, I think. I think that it could be needed sometimes to see all these values as all the same. Another point is, should the function that we pass to the continuation be able to throw? And in this case, should the implementation use a try-catch in order to recover the exception? This could be possible if the error is exception pointer, but it is error C. We are not able to do the translation. Then, currently, we have decided that the function should not throw. And we could add some adapter that, in the case of exception pointer, could do the try-catch. Yes?
I think for the sake of composability, fmap should allow any function, including a function that throws. Now, mbind is different because mbind takes a function that already returns.
Yes, and could say with the result type that there is an error already, but not fmap. You combine me, yes. The question was, sorry, that it is not the same case between fmap and mbind, because mbind returns already unexpected, and it is able to say that there is an error. But fmap,
Should take any
less.
I step back a little bit here, and I kind of review what's been going on. And you started out with the original structure. Hey, okay, I see it's optional, but it has another member in it to indicate why the thing is empty. Okay, kind of makes some sense. And then you follow the whole thing, and you keep adding more and more machinery, and to deal with, I would say, kind of more and more narrow cases to the point I can't even keep track what it is anymore. And I'm wondering if one step back in the beginning said, you know, what we should, if I'm sitting in my cubicle like with a ripping headache, the guy next door comes over, he says, look, I got a function that's going to return either one of a couple different kind of errors or the value. I would say, especially since I got this big headache, just use boost variant and just specify each error type and the value type, and then do whatever you have to do to make it work. And then you would have something that you don't really have to read, I don't know, a couple pages of code, or excuse me, a couple pages of documentation to just figure out what the thing did. I'm wondering if we haven't really over-engineered the whole concept. Or maybe,
Okay.
let me put it a different way. That Andre's original idea seemed attractive when it was proposed, but when you bring it to its logical conclusion, maybe it loses its original appeal. I don't know, I'm not really asking for a response. I'm just kind of
The comment is, I tried to resume, is that for Robert, it seems that there is over-engineering on this design, and that maybe using variant will be enough. And
You would
I-
a use case or example,
I
and then,
propose you, Robert, to just use variant and write the examples that there are on the slides.
Yeah, that's
Just there are
that's fair.
very sample examples. Write them.
It seems like the whole idea of adding a monadic syntax is independent of this class right here.
Right.
And I wonder if it might come across as confusing because there's really two things going on. And actually, I think the monadic syntax is probably the more sophisticated of the two. So I'll just throw that out there.
Yes. The comment is that the monadic syntax it is not as specific to this class, and that it will be great to have this for all monads, but we don't have neither the syntax for monadic syntax. We have only libraries.
So in a language that already has built-in exceptions,
Yes.
what does this bring?
Do you know a language that has built-in exceptions? Is the question?
No, what the benefit is to not use exceptions, but this.
Well, I can take into account that you don't have always exceptions, and then expected error C, it is a solution, a possibility. Even when you use exception pointer, you are not using exception machinery until you decide to get the value without knowing if the value is there or not. That means that it is up to you to decide when you use if then else like code or an exception code. But you can decide it later on, and you are able to propagate you can use also this expected type in order to propagate values between threads, even if the values are already ready, but because you transport either a value or an exception. It is not a feature because value is ready at construction or before this transferring. This is another use case you could have. You could have callbacks that give you this value or an exception also. Exceptions are there and very useful. I am not saying that, and take into account that this library don't prevent from exceptions. Only the exceptions that you want to transfer using this mechanism are stored like that. But a lot maybe don't go to this case.
If I could return to the should FMAP expect that the continuation doesn't throw, you were asking whether, whether expected of ET throw E instead of add expected access, and whether we should have a separate class for exception pointer. I wonder if it would make sense to consider a design in which there was no first parameter to the template if the exception, if the...
To have an expected T.
But what you get is always exception pointer, and when you have another type, you construct an exception of bad expected access that binds that type, and produce an exception pointer eventually for that. That would allow you to be transparent about the FMAP.
Yes, but I don't want to pay for an exception pointer when I can pay an int. The question was, why don't implement expected ET in function of expected exception pointer T? The goal to add this parameter was to be more efficient in these cases. Then I think that in this case it is better to have only an exception pointer implicit error, and we had only one class, and you move your error type directly. So.
Two quick questions. You might want to consider standard less, doing something different than operator less. Standard less, then you can order them into containers.
Sorry, I didn't understood. Could you repeat?
Standard less, right? Overload standard less, because that's what map and things use.
Yes.
And have it work slightly differently than operator less than, because
I have not considered it.
Right, because that's where you might decide how to handle
the question was, have we considered to specialize standardless? Yes, I know.
My last question is, why is it E comma T and not T comma E?
Yes, important. Yes. Initially, the question is why it is not expected TE. And I have changed that in order to be able to use expected E as a type constructor. Because the monad, when we working in order to try to make all these things as monads, the monad is not expected ET. The monad is expected E.
But that's Haskell, right? In C++, if you say expected int, that means I kind of expect an int.
Yes, yes. Maybe Originally, and the default error was also exception pointer. Then you state expected int. It is what quite clear. I am not happy with the change. I have changed it in order to be able to use expected error C as subtype. Maybe we need another class in order to name the type constructor. Probably. Because it's more natural to use expected int. That.
So,
More question?
okay, I can
Last question.
ask you.
Okay, thank you.